Good evening, everybody. Welcome to another edition of Final Countdown. This is week number 6, day 1. Week number 6, day 1. And today we'll be discussing the 2005 A-level question paper. 2005 A-level question paper. So as usual, 20 MCQs, one structured, one essay. Right. Let's get back into work. Right. Have a look. The variation of the rate of decay of a radioactive sample with time t is given by the relationship A equals A naught e to the power minus lambda t. E to the power minus lambda t. They are asking you, what is the dimensions of lambda? So remember, minus lambda t is a value. Whatever you put here is going to be a value. So minus 1 dimension, lambda dimension, t dimension is a value. Values are dimensionless. So lambda dimension is equal to 1 over t. In other words, t to the power minus 1. T to the power minus 1. Right? T to the power minus 1. Okay. Moving forward. Next one. In the equation, C equals K over rho, units of K are. So here, square both sides. K is equal to C squared rho. K is equal to C squared rho. If you simplify this, C is going to be speed, so meters per second squared, kg m minus 3. M squared m minus 3, kg m1 s minus 2. Kg m minus 1 s minus 2, answer number 4. Answer number 4. Right. Moving forward. A capillary rise of water. What do you mean by capillary rise? In a tube, according to surface tension, there is going to be capillary rise. Right. Capillary rise is given 2t cos theta divided by r rho g. R rho g. They are saying when the angle of contact between the glass and the water is 0, height is h. Theta equals 0, cos 0 is equal to 1. From this, h is equal to 2t over r rho g. 2t over r rho g. Right. Now the angle of contact is 90. Theta equal 90. Cos 90 is equal to how much? 0. Cos 90 equals 0. If cos 90 is equal to 0, if you substitute here 0, h is equal to 0. So capillary rise is equal to 0. Answer number 1. Answer number 1. Right there. Capillary rise occurs due to surface tension. Capillary rise occurs due to surface tension. So this is your governing equation. Nah? H equal 2t cos theta divided by r rho g. R rho g. Next one. 3 identical blocks are placed on each other as shown in the figure. Center of gravity of the setup is. Look at the board carefully. Look at the board carefully. Now, whatever happens, this is on the verge of toppling. On the verge of toppling. When it's on the verge of toppling, the center of gravity of the system should pass through the edge of the table. Center of gravity of the system should pass through the edge of the table. That means total weight should pass through the edge of the table. And that is passing through B. That is passing through B. Correct answer, fourth one, answer number 2. Correct one, fourth one, answer 2. Right there. On the verge of toppling, the total weight should pass through the edge of the table. The total weight should pass through the edge of the table. The total weight should pass through the edge of the table. Total weight should pass through the edge of the table. And the line of action of the weight passes through B. And the line of action of the weight passes through B. Line of action of the weight passes through B. Okay. Right. Moving forward. A violin string of length 0.5 meter is tuned for a fundamental frequency 440. So all of you all know F proportional to 1 over L. 440 proportional to 0.5. Equation number 1. To obtain a fundamental frequency of 550, at what distance should the finger be placed? Now the mistake in this question is they have not told from what end. Here the length is equal to 0.5 meters. Now 550 new length is L dash, equation number 2. First equation divided by second equation, 440 divided by 550, L dash divided by 0.5. So here 11 times 4, 11 times 5. L dash equals 0.4. L dash equals 0.4. Now these where the problem starts. Now this 0.4 is from where? So we can take 0.4 from here. 0.4 from here. We have to keep a finger. That means from this side 0.1 meters. These are possible. What if I measured from this end 0.4? If I measured from this end 0.4, then 0.4 meters also accepted. 1 and 4 both can be accepted because they are not told from what end. Here. So in this particular question, 1 is also correct logically, 4 is also correct logically. Basic theory remains the same. Theory remains the same. Okay. Right. Okay. So don't forget, basic theory remains the same. Right. Basic theory remains the same. Right. Moving on. Question number 6. Question number 6. Have a look. Have a look. In the circuit shown, R is a variable resistor with a sliding contact. P and S is fixed resistor. Which of the following circuit is most suitable to verify Ohm's law? To verify Ohm's law. Now verifying Ohm's law means across the resistor there should be a potential difference or voltmeter. And you're changing the current in the circuit. There. So you're changing the current in the circuit to measure the voltage. Now this can't be true, because ideal voltmeter means current is 0, you can't measure. Here also same, you can't measure. Here also you can't measure. Now current is coming this way. When you change the slide, what happens? When you change the slide, potential difference changes. Potential difference changes, the current in that part of the circuit also will change. We never connect it in series here, current will not pass through. Current will not pass through. Here. So here if you look at it carefully, here also current will not pass through. So most suitably if you look at this, when I change the slide here, effective resistance, so the resistance here will change, potential difference will change. Potential difference changes, current also will change. Most suitable is answer number 3. We never connect A and B in series. We never connect A and B in series. And voltmeter we never connect in series. Current will not pass through. Current will not pass through. Okay. So most suitable is answer number 3 right there. When we change the sliding contact, the resistance will change, causing the potential difference to change. The resistance will change, causing the potential difference to change. Keep writing. When the potential difference changes, the current in the circuit will also change. When the potential difference changes, the current in the circuit will also change. Okay. Right. Moving forward. Question number 7. Hydrogen gas is introduced into a container having helium gas until the pressure is doubled while keeping the volume and the temperature constant. So this is like Dalton's law of partial pressure. There is a pressure P, I insert hydrogen, now the pressure became 2P. Right. Ratio of the number of helium atoms to the number of hydrogen atoms. Now look at this carefully. PV equals nRT. PV equals nRT. Right. Pressure P, if you look at this, volume is V, number of moles N1, this is for helium RT. Pressure P, volume V, number of moles of hydrogen RT. Pressure created by helium is P, hydrogen also doubles, so P. Ratio, if you divide one by the other, because temperature same, volume same, number of moles of helium to number of moles of hydrogen, 1 is 1 ratio. Correct answer is answer number 3. Right there. From Dalton's law of partial pressure, after inserting hydrogen, the pressure has doubled. This means the partial pressure of hydrogen is also same as the partial pressure of helium. The partial pressure of hydrogen is also same as the partial pressure of helium. Right now? Okay. A given parallel plate capacitor is connected to a battery. When the EMF of the battery is doubled, the electric field between plates. Look at the board carefully. Now I am connecting a capacitor to a EMF. Connecting a capacitor to a battery. What are they saying? When the EMF of the battery has doubled. So when the EMF of the battery has doubled, the potential difference across the capacitor also will double. So if you look at this carefully, here potential difference is E, here potential difference is 2E. So the electric field between the plates, electric field is equal to potential difference divided by distance. So potential difference increases means electric field increases. Potential difference double means electric field also will double. 2 times PD means 2 times E. So your correct answer is answer number 3, doubles. Right there. when the EMF doubles, the potential difference across the capacitor will also double. The potential difference across the capacitor will also double. Potential difference across the capacitor will also double. Therefore, the electric field will also double. Electric field will also double. Okay? Right. Operational amplifier circuit. First, is it a closed loop or an open loop? So, looking at this, closed loop. Why closed loop? Output is connected to the input. Right. Then you have to apply golden rule number 1. If it's closed loop, golden rule number 1. What is it? V plus equals V minus. Now V plus is equal to V input, that is equal to V minus. V minus is connected to this point P. Therefore, V minus equals Vp equals V input. Right, voltage input. Current travels from high potential to low potential. Let's say current is traveling this way. That's how current is traveling. Why? Input resistance is infinite, no input current. So all the current that is coming this way will go across that. Okay. So if you look at this carefully, because you know potential divider, here there is a resistor, here there is a resistor grounded. This connected to point P. P is connected to the negative part, V minus. Here V output. So what is your voltage P? Vp is equal to resistance times total voltage divided by the addition. RR cancel off. From this V minus or V input can be found. Right. So RR cancel off. V input is V minus. V output divided by 2. They are asking the gain. Gain is V output over V input plus 2. Plus 2 is your answer. Ninth one, answer number 1. Ninth one, answer number 1. So golden rule number 1, V plus equal V minus. This part of the circuit separately draw. Output voltage grounded. Vp here is voltage from here. R times total voltage divided by the addition. From this you can get the V input value. So gain is equal to output over input plus 2 plus 2 plus 2. Right? No? Right. Next one. Consider the following statements made regarding refraction of light. Refraction of light. Consider the following statements. Refraction of light. Refractive index of a medium is equal to speed of light in vacuum over speed of light in medium. Correct? A light wave travels from one medium to another. Frequency does not change. Correct? Wavelength of light is reduced when it passes from vacuum to medium. Rarer to denser means velocity in rarer medium is greater than velocity in denser medium. Therefore, wavelength in rarer medium is greater than wavelength in denser medium. So, wavelength reduced when it passes from vacuum to medium. Correct. A, B, C all are correct. A, B, C all are correct. A, B, C all are correct. Right. Moving forward. Right. The period of an object performing simple harmonic motion depends on the amplitude of the oscillation, speed of the object at the equilibrium position, initial position of the object, For example, we'll take spring mass system. Spring mass system periodic time. E equal 2 pi square root m over k, right? Then take simple pendulum. E equals 2 pi square root L over G. Right. Now from these two, look. Amplitude. Somewhere do you have amplitude? No. Speed of the object. Somewhere do you have the speed? No. Somewhere do you have the initial position or initial phase? No. A, B, C are not true. Correct answer is answer number 5. Right there. Right there. If we consider the spring mass system or the simple pendulum, we can easily show that. The periodic time doesn't depend on any of the given statements. The periodic time doesn't depend on any of the given statements. Okay. Right. A glass vessel of volume V is completely filled with liquid of expansity gamma 1. Volume expansity of glass is gamma G. Temperature of water is increased by theta. The volume of liquid expels from the vessel. So volume overflowing. Overflowing means gamma apparent. Gamma real equals gamma apparent plus gamma of the vessel. Gamma real liquid gamma 1 or gamma L. Gamma of the vessel gamma glass. Gamma apparent is equal to gamma L minus gamma glass. Now you can find the apparent volume expansion. Apparent volume expansion initial gamma apparent delta theta. V gamma 1 minus gamma glass theta. Delta V apparent is overflowed volume. V gamma 1 minus gamma G. V gamma 1 minus gamma G into theta. 12th one, answer number 1. 12th one, answer number 1. Right. A 100 microfarad capacitor is connected in series with a 10 kilo ohm resistor. The charge stored in the capacitor in this circuit at steady state is, if you apply Kirchhoff law here, sum of EMF equals sum of potential differences, minus to plus positive, voltage across the capacitor is there, V cap, there is no voltage across the resistor. Voltage across the capacitor, that's going to be 5 volts. Voltage across the capacitor, that's going to be 5 volts. Look at the board now. So charge stored is Q is equal to CV, 100 microfarad into 5, 500 microcoulomb. 500 microcoulomb, 10 to the power minus 6 coulomb. 10 to the power minus 6 coulomb. 5, 10 to the power minus 4 coulomb. 5, 10 to the power minus 4 coulomb. Correct answer is answer number 2. Correct answer is answer number 2. 13, answer number 2. 13, answer number 2. So remember, at steady state, there will be no current passing through. At steady state, there will be no current passing through. So you can apply Kirchhoff law. Once you apply Kirchhoff law, you can get the required answers. So we've been doing many problems with capacitors. All these problems with capacitors at steady state, no current is passing through. Right. Question number 14. Question number 14. Figure shows two identical pulsars moving towards each other along a string. The two instances where two pulsars overlap each other. Now here there is a vertical displacement. So when they superimpose, the resultant will increase and they travel as if nothing ever happened. Correct answer is answer number 2. So resultant displacement is the vector sum of the individual displacements at a particular point. So once they meet here, this wave and the other wave they meet, they superimpose to a bigger wave. They superimpose to a bigger wave. They superimpose to a bigger wave. Once they superimpose to a bigger wave, after superimposing, they travel as if nothing ever happened. Correct answer is answer number 2. Correct answer is answer number 2. Right. Okay. Next one. 4-point charges, each having charge q, are on the circumference of a disk. When the disk is rotating about the axis, so rotating means charge is also moving. With n revolutions per second, frequency is given. The mean current in the circumference is, so q is equal to it. Total charge 1, 2, 3, 4. 4 simple q plus current into time. 4q divided by t is current. 4q divided by t is current. Now look at this carefully. I is equal to 4q, 1 over t is frequency. 4q frequency. Frequency is number of revolutions per second. 4qn. 4qn means answer number 3. 4qn means answer number 3. 15th one, answer number 3. Right. 15th answer number 3. There you go. Right. Good question. The concentration of water vapor inside a closed room is 24 gram per cubic meter and the relative humidity is 60%. So RH equals 60% means unsaturated vapor. Don't forget. Unsaturated vapor. Unsaturated vapor. If the air inside is made to saturate with water vapor at the same temperature, the new water vapor concentration inside the room is, right, RH equals absolute humidity divided by absolute humidity at saturation multiplied by 100. Look at the board. RH equals 60%. Absolute humidity is 24. Absolute humidity at saturation, same temperature, into 100. Simplify this. Simplify this. So that's your rule, no? That's your rule, no? AH at saturation is given 24. Now AH at saturation 24 into 100 divided by 60. 20 times 5, 20 times 3, 3 times 1, 3 times 8. 40 gram per cubic meter. Right. 40 gram per cubic meter. Okay. The new water vapor concentration is, so if you want to saturate, you should have what, 40 gram per cubic meter. 40 gram per cubic meter means answer number 3. So for saturation to take place, we need 40 gram per cubic meter. I have 24. If I can give 16 more, I have 24. I need 40 for saturation. This for saturation. For saturation, I have 24, I need 40. If I can give 16, saturation will take place. So they ask in new water vapor concentration 40 gram per cubic meter. 16th one, answer number 3. 16th one, answer number 3. Okay, no? Right there. When RH or relative humidity is at 60%. When relative humidity is at 60%. When relative humidity is at 60%, it is an unsaturated vapor. 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 We can find the absolute humidity at saturation. We can find the absolute humidity at saturation. We can find the absolute humidity at saturation. We can find the absolute humidity at saturation, which is 40 gram per cubic meter. Which is 40 gram per cubic meter. Which is 40 gram per cubic meter. So if we can add 16 grams per cubic meter more, if we can add 16 grams per cubic meter more, saturation will take place. If we can add 16 grams per cubic meter more, saturation can take place. Saturation can take place. Okay, no? Right. A metal block X of mass M at temperature theta is made to contact with another metal block Y of mass 2m at temperature 100 degrees Celsius. Heat transfer takes place. Now how will heat transfer occur? High temperature to low temperature. No heat loss to the surrounding. The specific heat capacity of X and Y is Cx and Cy. Final equilibrium temperature. So heat given, somebody is giving heat, somebody is absorbing heat. Somebody is giving heat, somebody is absorbing heat. Who is giving heat? The one with the higher temperature. 2m Cy, temperature reduces 100 minus theta. Who is absorbing heat? The object with the low temperature. Mass m Cx, theta minus 0. Theta minus 0. Final equilibrium temperature of the metal is 20 degrees. Final equilibrium temperature is 20, right? So mm cancel off. 2 Cy, 100 minus 20, Cx, 20 minus 0, right? So 80 times 2, 160 Cy, 20 Cx, 20 Cx, right? So Cx equal 8 times Cy. Cx equal 8 times Cy. 8 times Cy. Correct answer is answer number 1. Correct answer is answer number 1. Correct answer is answer number 1. Right. Correct answer is answer number 1. Right now, high temperature object will give heat. Low temperature object will absorb heat. High temperature objects will give heat. Low temperature will absorb heat. Right. Figure shows 3 identical bulbs, same resistance. Remember, if they say identical bulbs, same resistance, which are lit by battery with 0 internal resistance. The ammeter has negligible internal resistance. Filament of one bulb breaks. Filament is breaking means resistance infinite. If a filament bulb breaks, no current will pass through, resistance is infinite. Right. What will happen? Remember, brightness depends on potential difference. Brightness, potential difference across bulb. When potential difference reduces, brightness reduces. Potential difference increases, brightness increases. Right. Now when one bulb goes away, one bulb is not working. One bulb is not working. Potential difference here E. Potential difference here is also E. Potential difference here is also E. Potential difference will not change. When one bulb breaks, potential difference same. Potential difference same means brightness also what? Same. Remember, brightness depends on potential difference. Therefore, brightness same. Brightness is same, right? What can you say about ammeter? 3 resistors, R, effective R over 3. Now 2 resistors, R over 2. Resistance has increased, current will reduce. Effective resistance increases, current reduces, ammeter reading reduces. Right now? So brightness decreases, ammeter reading, brightness is same, ammeter reading decreases. This is wrong, this is wrong, this is wrong, this is wrong. Correct answer, answer number 5. 18, answer number 5. 18, answer number 5. Right now? So don't forget this, huh? Don't forget this. Brightness depends on potential difference across the bulb. Potential difference same means brightness same. Potential difference same means brightness same. Ammeter reading depends on the resistance. Effective resistance increases, current will reduce, ammeter reading also will reduce. Ammeter reading also will reduce. Okay. Correct answer, answer number 5. Correct answer, answer number 5. Correct answer, answer number 5. Right. Question number 19. Question number 19. A force 10 Newton is applied on the smaller piston of a hydraulic system. A force F1 is produced on the larger piston, area 4 cm squared. When the surrounding temperature is decreased, the liquid inside is solidified. The solidified block moves freely inside the system. The new force produced on Q due to force F equal 10 becomes F2. The respective forces are of F1 and F2 are, right, what are they saying? When you apply 10 Newton, there is going to be a pressure. Pascal's principle, pressure everywhere same. Hydraulic, no. Pressure everywhere same. Pressure everywhere same. When the surrounding temperature decreases to liquid, so F1 on the larger piston, force divided by area 2 centimeters squared, that is equal to pressure. Pressure equal 5 10 to the power 4 Pascal. The liquid, here pressure same. Pressure equal force over area 4 centimeters squared convert to meter squared. Pressure is 5 10 to the power 4, 4 10 to the power minus 4. F1 can be found. F1 is 20 Newton. Right. Now what are they saying? Now this becomes a solid. If this becomes a solid, here if I apply 10 Newton, here if I apply 10 Newton, here if I apply 10 Newton, they are asking the force produced here. Force produced here. Force produced there. Look at the board carefully. For a liquid, we can apply Pascal's principle. Pascal's principle. Right, Bill? For a liquid we can apply Pascal's principle. For a liquid we can apply Pascal's principle. And we can find the 20 Newton F1 force. And we can find the 20 Newton F1 force. We can find the 20 Newton F1 force. 20 Newton F1 force. But for a solid, the pressure applied, the force applied will remain the same. The force applied will remain the same. So no change. Here 10 Newton means, even here you have 10 Newton. Anywhere 10 Newton. So 20 Newton, 10 Newton. Correct answer, answer number 2. Correct answer, answer number 2. Right. Figure shows set of circle, stationary point charge Q. The circles could be, so these are charge. Charge means equipotential lines. Equipotential lines. So if there is a charge, these are equipotential lines. Equipotential lines. Equipotential lines. And you can see the gap between these lines increase. Why is that? Potential is inversely proportional to distance. R increases, potential reduces. To show that the potential reduces with distance, that is why with distance the gap will increase. With distance the gap will increase. Right there. Due to a point charge, equipotential surfaces occur. Due to a point charge, equipotential surfaces occur. Equipotential surfaces occur. Right. So 20 MCQs done. So moving on to a very famous structured essay. So principle of parallelogram of forces. Principle of parallelogram of forces. Right. First question. Give a list of other items needed to carry out the experiment accurately. So you need a set square in mirror and ruler. Set square and ruler. Set square and ruler. How do you test whether friction of the pulleys is negligible? So what do? You pull the center weight slightly down and release. If it goes back to the original position, no friction. If it doesn't go back to the original position, there is friction. So right there, pull the center weight. Pull the center weight Q down and release it. Q down a small distance and release it. And release it. If it goes back to the original position, if it goes back to original position, there is no friction. There is no friction. If it doesn't go back to the original position, if it doesn't go back to original position, there is friction. Right. Okay. Next one. If the above arrangement is set up for you, briefly explain what you would do, what you would adapt to verify the principle of parallelogram of force also. What do you do? What do you do? So these what you do? Place a set square perpendicular to the string and mark a point on the sheet of paper. Move the set square along the string, mark another point. Repeat the same procedure for the other string as well. Repeat the above procedure for the other string as well. And where all the string segments meet, mark a point as well. Mark a point as well. Right. Write that will. First one. Place the set square. Place the set square perpendicular to the string. Perpendicular to the string. And mark a point on the string. Move the set square and mark another point. Mark another point. Then what? Repeat the same procedure. Repeat the same procedure on the other string segment as well. Other string segment. Other string segment as well. Then what? Where all the strings meet, where all the strings meet, mark a point. Where all the strings meet, mark a point. Then what? Remove the sheet of paper. Remove the sheet of paper. Draw straight line proportional to the weight. Proportional to the weight. So we draw straight lines proportional to the weight and complete the parallelogram. Complete the parallelogram. So now parallelogram is complete. Then what do you do? Draw the diagonal. Check if it is vertical and measure its length. And measure its length. So again look. Place the set square perpendicular to the string and mark a point on the string and move the set square and mark another point. Repeat the same procedure on the next string segment. Where all the string segments meet, mark a point. Where all the string segments meet, mark a point. Remove the sheet of paper. Remove the sheet of paper. You will have 3 points like this. Draw line segments proportional to the weight. Draw line segments. Complete the parallelogram. Complete the parallelogram. Draw the vertical. Measure the vertical length. Measure the vertical length. This vertical length will give you what? Required unknown weight. In order to carry out the experiment, light string should be used. Why is that? If the strings are not light, tension will change from point to point. Tension will change along the string. tension will change along the string. Okay, no? Right. After completing the parallelogram correctly, a student noticed that direction of the relevant vertical is not diagonal. What's the reason? Many reasons are there. First one, there is tension in the string. Next one, we have not added weight of scale packs. Weight of scale packs. What else? There are knots along the string. There are knots along the string. What else? When the masses move, they touch the board, causing additional friction. Causing additional friction. So these are the reasons, carefully write it down. These are the reasons. Carefully write it down. Also you can write, pulleys are not in the same plane. Pulleys are not in the same plane. That is also a reason. Right. If the scale pans are not light, what should you do? Add the weight of the scale pans and redraw the parallelogram. So what you do is you add the weight of the scale pans, redraw the parallelogram. In this setup used, a student finds out the weight of the stone. Relevant sides of the parallelogram are used. Right, complete the parallelogram. Right. Once you complete the parallelogram, draw the vertical line. Vertical diagonal. Right. 1 centimeter is 2 Newton. How many boxes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There. What else? 1 centimeter, 2 newtons. So if you draw the parallelogram carefully, right. This is your diagonal. 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Here 3 centimeters. that will represent 6 newtons. So weight of object 6 Newton. Weight of object 6 Newton. Okay, no? Right. Read the question carefully. Read the question carefully. Here, figure shows a satellite having a cylindrical body S. Two identical panels A and B. This satellite is moving in space where gravity is negligible and rotates about the cylinder XY axis with 6 revolutions per minute. Omega 1 is given. The plane of the solar panel is perpendicular to X and Y direction. Radius is going to be 0.4. And moment of inertia of the cylinder is 6. For each solar panel, mass is 2, A 1.2 and B is 0.6. The moment of inertia of each solar panel, 1, is given by this equation. Right. Calculate the moment of inertia of the satellite about X and Y. Right, okay, simple. Moment of inertia of the satellite is moment of inertia of the cylinder plus 2 times moment of inertia of panel. Cylinder is 6. 2 times panel. Mass is 2. A squared plus B squared 1.2 squared plus 0.6 squared divided by 12. Divided by 12 plus mass times radius is 0.4. Radius is 0.4. 0.4. A is 1.2 divided by 2 whole thing squared. So moment of inertia of the satellite you can find in kilogram meter squared carefully. Kilogram meter squared carefully. Right. What's your answer? 10.6. 10.6. Moment of inertia. So moment of inertia at satellite is moment of inertia of the center cylinder plus both the panels. Scalar quantity, so you add it. Scalar quantity, so you add it. So 1 panel multiplied by 2 panels. Calculate the rotating kinetic energy of the satellite. So here you have 6 revolutions per minute. Omega 1 is 2 pi, 6 divided by 60, 0.2 pi. 0.2 pi. Simplify this. Simplify this. Pi you substitute 3.14. 826, 3 decimal. 0.628 radians per second. 0.628 radians per second. Approximately 2 decimal places. Exam day keep for 2 decimal place. 0.63 radians per second. So rotational kinetic energy. Rotational kinetic energy is half I omega squared. half moment of inertia 10.6, 0.63 squared. You get your answer in joules. You get your answer in joules. 2.1 joules. 2.1 joules. But they are given in the marking scheme between 1.9 to 2.15 give marks. In this range they are given marks. Right. Next one. If the two solar panels are folded, so new moment of inertia of each panel becomes quarter of the previous value. Calculate the new moment of inertia and the new angular velocity. Right. So new moment of inertia, cylinder moment of inertia, 2 times quarter of the earlier moment of inertia of panels. Quarter. Right. Here 6. Do the substitution. 2 times 1.2 squared plus 0.6 squared divided by 12 plus 2 times radius 0.6. 2 times radius 0.6. 0.4, 1.2 divided by 2 squared. 0.4, 1.2 divided by 2 square. Simplify this. New moment of inertia you can find. New moment of inertia you can find. 7.15 kilogram meter square. 7.15. What about the new angular velocity? New angular velocity you can find here. I1 omega 1 equals I2 omega 2. 10.6. 2 pi 6 over 60. 7.15. 2 pi n over 60. 2 pi n over 60. Angular velocity they want. Angular velocity means substitute here in terms of omega. 0.63. 0.63. Omega 2 is 10.6, 0.63 divided by 7.15. 10.6 times 0.63 divided by 7.15, 0.93. 0.93 radians per second. Remember the law of conservation of angular momentum. Law of conservation of angular momentum. In the marking schemes they are given you a small range. 0.89 to 0.95 accepted. 0.89 to 0.95 accepted. Right? Okay. Next one. In order to control the rotation of the satellite, a mechanism is available to apply torque on the satellite along xy. This mechanism does not change the moment of inertia of the satellite. If the angular velocity of the satellite has to be brought back to the original value from the value calculated above by maintaining uniform angular deceleration for a period of 5 minutes, calculate the angular deceleration and the torque. Right. Omega equal omega naught plus alpha t. Now what has happened? 0.93, initial 0.63. Now 0.93, we have to bring it to 0.63. How many minutes? 5 minutes, 300 seconds. 300 seconds. So torque is bringing the object back again to the initial speed. 0.30 minus divided by 300 is alpha. Alpha is minus 3 over 3000 minus 0.001 radians per second square. Angular acceleration 0.001 deceleration. Then your torque is equal to I alpha. I alpha. They are telling you here, in order to control the rotation, the satellite mechanism is able to apply torque on, does not change moment of inertia of the satellite. So moment of inertia of the satellite will remain the same, 10.6. 10.6. 10.6. Or now it has become 7.15. Now moment of inertia is 7.15 folded. 7.15 Roman 3 case 7.15. So moment of inertia remains the same. 7.15 into minus 10 to the power minus 3 minus 7.15 10 to the power minus 3 Newton meter. Resistive torque applied 7.15 10 to the power minus 3 Newton meter. 7.15 10 to the power minus 3 Newton meter. Resistive torque. So in Roman number 3, moment of inertia is 7.5. Angular deceleration minus torque. Minus torque means resistive torque. Okay, no? So for Roman number 3, I doesn't change. Roman number 3, I is going to be 7.15. So for 7.15 not to change, what is your resistive torque acting? Right. Determine the energy required to bring the angular velocity back to the original. Increase or decrease in work done here. Work done by external torque. Determine the energy required to bring the angular velocity of the satellite back again to the original value. There's a torque acting. So let's write in words. Work done by external torque. Equals increase in rotational kinetic energy plus work done by resistive torque. Look at the board carefully. There is a loss in rotational kinetic energy. There is there external torque? No external torque. Is there a resistive torque? Yes, there is a resistive torque. Increase in rotational kinetic energy is final rotational kinetic energy minus initial rotational kinetic energy. Work done by resistive torque. There is no external torque, so that means velocity will increase. So work done by resistive torque here you go. Half 7.15 0.93 squared half 7.15 0.63 squared. Work done by resistive torque, how much? (1.7 joules). 1.7 joules. So I've applied work energy principle. Final minus initial, work done by resistive, so speed is reducing. There can't be external work done, only resistive work done. Once you have resistive work done, you can find the required answer. Right. Okay. Right now? Right. Have a look. So this concludes week 6 day 1. Week 6 day 1. So 6 weeks, 6 weeks, week 6, day 1 done. Day 1 done. So how much we have done? 320 MCQs done. 320 MCQs done. 16 structured essay done. 16 essays also done. You know, 16 essays also done. 16 structured essay, 16 essay also done. You know, so therefore, now this week we'll complete. We'll bring this tally to how much? 360. This to 19. This also to 19. Okay, no? Right. So keep working. So I'll meet you again tomorrow, week 6, day 2 discussion. Stay home safe.